Now this project is fairly large. It's almost 15 inches tall and over 4 inches in diameter. We use the design kit. That allows us to work out all of the cuts in the design on paper before we ever start using the machine. It also helps to identify some potential problems. For example, right here, the router bit will cut evenly on this side and on this side and would ruin this corner. So to get around that, we are going to break this piece into a couple of components. This is the original design. Once I had this worked out, I then drew up this section here that shows all of the components, from the base, the middle section, the hollow spiral, and the cup. We're going to start by working on the hollow spiral section here in the middle. You can see this section right here that we're going to build, and it will be joined into the top and the bottom here with this half-inch dowel that's machined on each end of the part. So we'll start off making a blank that's 3 inches square, and we'll turn it round, and then we'll do the hollow spiral section, and then last of all, we'll come back and cut the tenons. This will then be parted right here at this point and removed, so it'll plug into these sections here. Now, if you ordered the plans for this project, then you will see that this is a three-dimensional representation of this part. The plans will spell out the dimensions for the diameter and the position of each cut. It will also have the instructions or the formula for the hollow spiral, which router bit to use, what pitch you'll use, and the spacing between each cut, and so on. This is just one drawing for this component, and of course you'll get complete drawings for all of the parts. We prep the stock so that it's over 3 inches square, and then we've taken the corners off. Now we'll turn this to a 3-inch diameter. To mill the stock round, we'll use Magnate's bit number 2704, which is an 1.25 inch diameter surface planing bit. Okay, 3 inches. We're ready to go to the next step. When I drew this up on the design kit, I decided to use a 2-inch diameter barley twist router bit and 3 starts, so we used a 6-inch pitch. Now when you get your plans, it's going to call that out right here on these instructions. 2-inch barley twist router bit, 6-inch pitch, 3 starts. The spacing between each cut is going to be 2 inches. For the 6-inch pitch, we're using the standard gear reduction set here and the F drive gear. And we've got the single gear on here for the left-hand spiral. We'll use bit number 7552, the 2-inch diameter barley twist, and we want to set the plunge depth so the shoulder of the bit is just touching the surface of the wood. At this point, I'm going to zero the scale, and I'm going to lower the router bit an additional 15 thousandths, just to ensure that we're skimming off the surface of the wood. We'll set the stop at that point. Referring to the drawing, we set a stop at 10.5 inches at this end and 2.5 inches at this end. Now I'm going to lock this onto the lead screw so it won't move, and we'll cut around the circumference of the part. I'm going to cut the same profile at the opposite end, so we'll lock it down here. The plunge depth is already set. To cut the barley twist, I've positioned the router right at 0 over the center of the stock, and I'm going to put a stop right there So each time I bring the router bit in, it'll always be at the same position. Now we'll want to back it off so that when we turn the router on, it's not touching the wood. We'll bring it to the center point, and then we will cut towards the headstock end. At this point, we're going to open the split nut, and we're going to slide the carriage back 2 inches. That's the diameter of the router bit. We'll lock it back onto the split nut, and then drive it back to our starting point, which is at 10.5 inches, and then make our second cut. Let's look at the plans carefully to see where to set the stops for the hollow spiral section. On the design kit, it's centered at 3.5 inches and at 9.5 inches, and it's also specified here on your plans as well. To cut through the hollow spiral, we're going to use a 1/2 inch 2-flute straight cut. This is Magnate's bit number 285B. So we set the stop at 3.5 inches at this end, and then we would set it at 9.5 inches on this end. However, I'm actually going to set my stop back 1/4 of an inch. The reason I move it back to 1/4 is so that when I drive this up to this point, I'll have gone past my starting point. I will then drive it back the 1/4 of an inch, and that will remove any backlash in the system. As we start our cut, you won't get any run out. You'll want to align this with the center of the previous cut. So we'll drop the router bit down into that position, and then we'll go ahead and close the split nut at that point. Now we're ready to come up to our starting point, which is a 1/4 of an inch past it. Come back to this point and start cutting the hollow spiral. Now obviously we can't cut this all in one pass, so we're going to make about 1/8 of an inch cut on each pass. Once we've cut to the final depth, we need to open the split nut and slide it back 2 inches, the same as before, and make our second cut to the center. Again, we'll go to the stop, which is past 1/4 of an inch, and then bring it up to that point and start cutting. Obviously, you could cut a hollow spiral like this by hand, but it would be much more time consuming. You'll also notice that this is going to require very little sanding. Now in the next step, we'll go ahead and cut the round tenons or the dowels on each end to put the part together when we're finished. Position the router at 10 3/4, which will put this edge of the router bit in the center of that cut. Now we'll test cut, and then we'll measure it and recut it to a 1/2 inch. Now this is measuring just about 30 thousandths of an inch oversize, so we only need to plunge down 15 thousandths of an inch. Now we'll move the router over 2 turns, which is a 1/2 inch, and we'll make the other cut. You'll notice that by bringing the router bit in from the back side as we make this cut, it gives us a nice clean shoulder on the right-hand side, and we get a little tear out on the left. When we cut at the headstock end, we'll cut from the near side, and that will give us a clean cut shoulder on the left. So I position the router at 2 1/4 inches, and we'll cut from the front side. The next step is to prepare the parts for the next 3 parts. These will become the base. This, of course, is the middle section, and this will be the cup up here at the end. On this section, we simply drilled about a 1/2 inch, or excuse me, 1 inch deep with a 1/2 inch cutter and mounted the hub on this end. We'll work on this section next. Referring to the drawings, we know the position of each cut and the router bit number and how deep to cut. Now we're doing the same process we did before. I make a test cut here, measure it, and then make an adjustment to the plunge depth, and we'll machine this to 4 inches. The next step is to use bit number 7503 and make these 4 cuts to form these 3 beads. For bit number 7503, we plunge the shoulder of the bit down till it touches the surface of the wood. This is our plunge depth. We'll make 4 identical cuts along the x-axis, starting at 2 1/2 inches. So I'll position this at 2 1/2 and lock it onto the lead screw for the first cut. The second cut will be at 3 inches. We will move it over 2 turns, or a 1/2 inch, and make the second cut. We'll repeat this process on the second part while we've got it all set up. Now the next cut is positioned at 5 3/8 of an inch, and we'll plunge down from that surface 1/4 of an inch. And we've made these 4 cuts here and this cut right here. So now we can change the router bits and just look on this drawing to know the position in the x-axis and also the depth based on the surface right here for each cut. Now we'll cut the 1/2-inch tenon at this point right here. Now we'll just part that off, and this part is complete. Let's just do a test fit real quickly and see how things are coming together. All right, now we just need to cut this off on the bandsaw, turn the base, turn the cup, and we'll be finished. We want to mount an index hub on the end of each part, like you see here. On this one, we have to mount the index hub on the top side of the cup because the tailstock will go into the mortise. So I laid it out upside down, so 0 was at this end right here. This is the blank for the cup right here. You'll notice that we've already drilled the hole, which is the mortise that goes in the end, and your tailstock will go into that hole. So the hub has to mount on the back side here, which is right on the end of the drawing like this. It's very critical that the hub is centered to that hole. Otherwise, the part will wobble when you put it in between centers on the machine. So here's how we'll do it. We started off by drilling this small pilot hole in the center, and we drilled all the way through the block. Then we came back with a 1/2-inch drill bit and drilled right down the pilot, but not all the way through. It's 1 inch deep, according to the drawing. Now what we can do is take the hub, and using a number 8 wood screw, we can center it on the part exactly and mark these holes, and then screw the hub into the part like this, and that way the two will be perfectly centered. We took the part and mounted the hub to the end of it, and then went to the bandsaw and just roughed it, slightly oversized. Now we'll use the machine to turn it to around 4.5 inches in diameter. The next step is to mill the cup using the same method that we used when creating this part here. We simply read off the plan, the router bit, the position and the depth of each cut, and then we mill around the circumference to form the cup. Now we finished the cup for the top. we're going to do the same process on the base. Of course, we've mounted our hub, and we have the hole drilled on the opposite side, 1/2 inch in diameter. And we've put that between centers in the machine, and we'll go ahead and turn this round according to the prints. Now all the components have been turned on the machine. The next step is to sand them. And if we were to sand these all by hand, of course, it would take forever and be a very hard process. So we're going to use a sanding mop, put this onto our drill press, and I'll show you how that works. Now that the parts are sanded and ready to finish, let me show you how the assembly will go. The first thing that we'll do is to take the cup, and I'm going to take a long wood screw and insert it through the hole in the back. And screw that up through the base. This will be used to mount the candle. Start off with the base. Put this bottom section on there. Next comes the hollow spiral. And last is the cup. Once the parts are all sanded, we used a little Titebond 2 and a couple of clamps to hold it together as the glue dries. Now we're putting the finish on the candlesticks. We're using Waterlux Original. This is a tung oil based product that will finish and seal in just a couple of coats. It's very easy to apply, very easy to work with. We'll just put the first coat on, and we'll let that dry thoroughly, and then come back and add a second and then a third coat, and that'll finish it.